So this question is called 100th digit. It says, what is the 100th digit to the right of the decimal point in the decimal representation of 1 plus root 2 to the power of 3000? So for this question, we're going to use the conjugate to manipulate the values and get the answer. So firstly, we have to know the binomial theorem that says 1 plus root 2 to the power of, like, call it n, any value for now. It's the summation from k equals 0 to 3000 of 1 to the power of n minus k, and then root 2 to the power of k. And if you know the conjugate of 1 plus root 2, it's just the same thing, but take the plus and make it a minus. It's 1 minus root 2 of n in this case. And again, we can take the binomial theorem of this and expand it out. K equals 0 to 3000, and then 1 to the power of n minus k, and then negative root 2 to the power of k. And so the 1's just go away because whenever you raise 1 to any power, it just stays at 1. So I can just get rid of this for now. Okay, so we have these two summations. And to note, so like let's say we have, if you add these up like this, 1 plus root 2 of n plus 1 minus root 2 of n, and then you subtract back out the 1 minus root 2 of n. Like, so you basically, these can cancel out, and you have your original value here, like your original, like what you're trying to solve. But if you combine terms this way, and then address this value separately, you're able to solve the question using some manipulation of variables and numbers. So, okay, so now we have this. If you observe the pattern of k as it goes from 0 to 3000, you can see when k is equal to 0, we have, let's say we have root 2 to the power of 0 plus, right, because we're going to add these up, plus root 2 to the power of 0. And that's just 1 plus 1. So we have some integer now, right? So then we can keep going. What if k is equal to 2? Or k is equal to 1? If k is equal to 1, you have root 2 to the power of 1, so it's root 2. And then it's plus negative root 2, so it cancels out. If k is equal to 2, you have, because they're raised to the even power and they're radicals, you actually going to get an integer out of this. So you're going to have 2 plus 2 equals 4. K equals 3, you're going to have, again, them canceling out because you have negative irrational plus a positive, the same irrational. So you're going to have them cancel out, and you're going to have some integer. Sorry, you're going to have 0 because they cancel out. K equals 4, again, integer. So as you go from 0 to 3000, you add integers, and then you cancel out irrationals, so your final result will be an integer. So we know that this addition is going to be some integer. Now we can address this. What is 1 minus root 2 to the power of n? It doesn't really matter what the exact value is, because we can see that 1 minus root 2 is like, I don't know, like 1 minus, root 2 is like 1.4 or something, 1.4. It doesn't matter exactly what the value is, as you'll see later why. You're going to get like negative 0.4 to the power of 3000. That's going to be an exponential decay, because like 0.4 squared is like 0.16, and then squared, like, and then times 0.4 again, you're going to get smaller, and you're going to get 0.048. You're just going to get smaller and smaller and smaller. You're going to have, eventually you're going to have so many zeros because it's the power of 3000. So it's going to be 0. Like 0, 0, blah, 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 like many zeros. Let's say like 1,000 zeros. 0 and then like a 1, for example. So you're going to have like 1,000 zeros. So we're going to have an integer, right? Because that's what this is. We're going to have an integer minus 0.0001. It's going to be some very small number. And this is going to be like 1,000 zeros. Okay. And if you have an integer minus 0.00001 all the way, like many zeros and then a 1, Then your answer is gonna be like an integer, some other integer, minus 1, right? Like some smaller integer, like one less. 0.9999999, like for like 1,000 nines, because of that 1 0, because of that this 1 1. And then so if you have like 1,000 nines, then your 100th digit will be a 9. And that's the answer. Pretty simple.